Good morning. So this week we're gonna be talking about volume, and we'll be finishing up chapter 12 this week, and that is our last chapter of the year, so that's some exciting stuff. So today we're gonna talk about how to find the volume of prisms and cylinders. And if you remember, prisms and cylinders all have two bases. So that's the big difference between pyramids and cones, which have one base each. And I think you'll actually find this a little easier than surface area, which is a good thing. So the volume of a solid is the number of cubic units that are found in its interior. So I always talk about this as thinking of, you're going to fill this solid up with rice or water or Skittles or whatever you're going to put inside of it. But we're trying to find the volume as if you filled it all the way up, how much can it hold? So the formula is much simpler. The volume of any prism or cylinder is just big B times H. Now remember that big B stands for the area of the base. So whatever your base is, you're going to take the area of that, multiply it to the height, and you're done. So this should be pretty simple today. So if you think about a cylinder, if the generic formula is big B times H, what do we know about the base of a cylinder? It's a circle. So what's the area of a circle is pi r squared. So the volume of a cylinder would just be pi r squared H. So naming these is really critical to being able to do them correctly. So if you look at example 1, remember to name them. It's what are there two of? And so this is a triangular prism. And I'm going to write that the volume is big B times H, but since it's a triangular prism, for big B I get 1/2 base times height. So don't forget there's two H's in this. So the first H is the height of the triangle. The second H is the height of the actual prism. And one more thing to talk about here that I forgot up higher. The height of a prism is the distance from base to base. So the distance that it takes to get from one base to the other. Okay, the other good thing about this triangle is you can see right there, there's a right angle. So this 3 is the base and 1 is the height of that triangle. So we get 1/2 times 3 times 1, all times the height. So this is the distance that attaches one base to another. So this height, the prism's height, is a 2. So this volume ends up being 3 feet cubed. Okay, next one, find the volume of this shape. So this is a cylinder. Volume is big B times H. So volume is pi r squared H. So we have a radius of 5 and then a height from circle to circle of 6. So 25 times 6 is 150. So a lot of people are just going to leave this 150 pi meters cubed. If you want to go ahead and multiply that out, you can, but you do not have to. All right. Like I said, I think you'll find this a little bit simpler than what we were doing last week with surface area. So this one says the volume of a right cylinder is shown, or the right cylinder shown is 1,253 cubic centimeters. Find the value of X. So if you look at X, they're actually asking you to find the radius. So volume of any cylinder is big B times H. So my cylinder's here. So that's pi r squared H. In this particular case, I know the volume is 1253 and I don't know R, but I also know H is 10. So we have to divide both sides by 10 pi. Just be careful, remember, when you're dividing by pi, sometimes I like to go like, I'll do 1253 divided by 10, enter, and then divided by 5, enter, or pi, sorry, because occasionally your calculator will get kind of goofy with that. So just maybe check your calculator as we do this one. So I'm going to divide it by 10. I'm going to divide it by pi. And that ends up to be 39.88. And then I'm just going to square root that. And that is about 6.3 centimeters. So most of what you guys are going to see is what we call a right prism or cylinder. Basically, they're standing straight up and down. But I do want to show you this Cavalieri's principle, which says that if two solids have the same height and the same cross-sectional area at every level, then they will have the same volume. So even though this is oblique, we can still find our volume of this using the same formula. So volume is pi r squared h. So the volume of this is pi times 5 squared times 8. So again, it's just 25 times 8, which is 200. So you can either write this as 200 pi inches cubed, or that is, oops, this calculator doesn't want to let me do that. Hold on one second, change my mode. 200 pi is 628.3. Okay, last one for today. It says a roll of paper towels has a radius of 3 millimeters. What is the volume of just the paper towels if the inner cardboard roll, which has a radius of 1 millimeter, is not counted? So you have big cylinder minus small cylinder here. So you kind of think the inside of a paper towel roll is, you know, it's hollow, it's empty. So we're going to go big B times H minus big B times H, the pi r squared H minus pi r squared H. So the only difference here is the radius. The big one has a radius of 3 and a height of 7. Whoops, that should be minus. And this one has a radius of 1, but still a height of 7. So this ends up being 63 pi. Take away 7 pi, so you can leave your answer in terms of pi as long as it doesn't tell you differently. So this will either be 56 pi, which is about 175.9, 175.9, and these should both be millimeters cubed. Okay, let me know if you have questions.